Welcome to part 2 of variables and data types in Java. Hope you enjoyed your coffee break. Let me start by making a formal apology for taking you to my kitchen in the last lesson and not offering you some coffee early on. But I promise if you stick with me to the end of this video, I'll show you how to brew some hot creamy coffee and use our coffee analogy to get a deeper understanding of data types in Java. Why don't we start by bringing some hot coffee beans to the table, as well as some hot water, sugar, and milk, which are the ingredients for brewing our coffee. Interesting enough, these ingredients represent what we call primitive types, which are the fundamental or building blocks of data manipulation. While our brewed coffee is of a more complex nature and it is called a reference type. This simply means that we have two categories of data types in Java. We have the primitive type and the reference type. The primitive type are simple data types for storing single values, while our reference types are used for storing more complex objects. In the previous lesson, I showed you a table of primitive data types in Java. Here it is again for your perusal. So you would notice that the title of the table shown above is primitive data types. And all primitive data start with a lowercase because these are key or reserved words in Java. But there's something we mentioned in our previous lesson which is missing here. Can you figure it out? It's a string. So the string is missing because it is not a primitive type. By convention, non-primitive types start with an uppercase. So anything that starts with an uppercase should raise an eyebrow. Talking about non-primitive types, also called reference types, we have some of the following, which are classes, arrays, enums, interfaces, as well as custom non-primitive types which you can create. For the purpose of this tutorial, I would talk about classes. In other classes, we have inbuilt classes that are created for us in Java, such as the system class, which we have used to print a line of text on the screen, as well as string. And we have also created some custom classes like the calculator class and the main class, which we are currently working on. So let's go ahead and show you how to create a variable of a non-primitive type in IntelliJ IDE. Now that we are on IntelliJ, you would notice this is not where we dropped off in the last lesson, and that's because I messed up the code while trying to prepare for this tutorial. Luckily enough, we have a way to revert our code back to how it was in the past. All you need to do is go to the class, right click on it and select local history. This will show you how your code has been in time past, and you can select a particular date and time to revert your code to. So I will just revert my code to on the 3rd, and which is this, and click on the revert icon. Now our code has been reverted, so we are good. We have established that strings are classes in Java and classes are reference types. If you put your cursor over this, you would see it says something like class string. And classes usually have what we call methods. Now, methods help perform specific actions in Java. If classes calling their methods were to be an English sentence, the variable name would be the noun, and the method that is called would be the verb. And we've shown an example of calling a method like in the system.println. The system is a class. You will see it says class. And then this print line is a method. So you see this method behaves. So this is a method. So we can do something similar with our first name here. And in order to do so, we would simply type the variable name and put a dot. Now, this gives us different methods that we can call to perform specific action on that variable. And I would like us to see to uppercase. And what this simply does is changes every character in the string to uppercase. So what it means is that by the time we print first name, it's supposed to change this first name to all uppercase. So let's run it and see if we get our results. Now you see it still says good day John with lowercase. Now why is this so? It is because whenever we alter a variable in Java, we have to reassign it to that variable. So we want to alter first name to all uppercase, but you will see there's a warning that says this is ignored because we are not reassigning the variable. To do so, we would simply type first name equals, and then we have first name dot uppercase. And by the time we run our application, you would see that John has now been changed to all uppercase. Let me show you another method in the string class which would give us an idea of the makeup of string. Now, strings are kind of similar to our brewed coffee in the sense that our brewed coffee is made up of certain ingredients. Strings as well are made up of a primitive data type called char, and we have a method char at. So let's go ahead and see how we can use this method. So if you type, okay, let me use last name this time. So if you type last name dot, you would see we have char at. Now char at is expecting an integer, which could be 0, 1, 2, 3, and the likes. And in this case, what this method does is it returns the character at a particular position. Now in Java, when a position usually starts from 0, 0 representing the first character in the string, and 1 representing the second character in the string, like that. So in this case, let's say we want to get the first character in the string, we'll put 0. And because we are not assigning this, it says the result will be ignored, just as we had for uppercase in our first name. So in this case, we can try and reassign it to last name. Now we have an error. This error tells us that required type is string but provided char. So what this char at method does is char at method gives us character in a particular position on the string. But in this case, this character is not of type string. It's of a primitive type called char. So that means that we have to create a new variable to store this char at. Remembering that we can no longer reassign, we can no longer use this name for a new variable because it has already been declared. So in this case, I will just say first char at last name. Now you see that char is in all lowercase. This is a primitive data type and it's a reserved word. So let's go ahead and print the result of our first char at name. And once we run this, you would see we have D, which is representing the first char at last name. Talking about char, char and strings are quite similar, but the difference is that char holds a single letter. So if we say letter A equals, and we have a pair of quotes, but this time around we have a pair of single quotes and a single character between the pair of quotes. So if you decide to put two characters, you will see we have an error message. So too many characters in literal. So char is a primitive type that stores a single character in a pair of single quotes. Aside calling methods of a class in Java, there are other things you can do with classes. But I'll touch on one more thing, which is instantiating or creating variables of type class. You have seen that to create a variable of type string, we simply do this. So we type string, the variable name, we assign it to a text between a pair of double quotes. But in reality, there is a generalized way of creating such variables. of reference types. So in this case, we're talking about creating variables of type class. And we can type string, we would say last name. Let's just comment out this. So we say last name and we assign it. So we'll type in new and then we type the class name with parentheses. So the format in comment would be we have class name, variable name, the new word, class name in parentheses. And we can type in do here. But the compiler kinds of advises us to remove this, and then we have the way we declared it previously. But for every other class we have, we surely can create variables of that class using these formats. And if you check our package, you will see we have two classes. Remember, we created this class in the first lesson. So we can go ahead and create a variable of that class by doing, we say calculators, and let's just call it calculators and assign it to, we'll type in new, and then we'll type calculators with parentheses and close this. Also, we can create a variable that makes reference to the system class that we use to print out messages. So in this case, we will type in system. Let's just say my system equals new system, and we end this. Now, this is meant to work, right? Because system is a class, but it gives us an error. Now, if we go to the declaration of this class, you would see it says, don't let anyone instantiate this class, and it is marked private. From our lesson 1, we talked briefly about the private and public keywords. So whenever a class is marked private, you cannot access that class. But if this was marked public, we should be able to create an instance of this class. So the system class does not allow us to create an instance of itself because it's marked private. And the system class is an inbuilt class in Java, which means we do not own them, just like the way we own our calculator class. So there's nothing we can do about this. We can't change this. The file is read only. But there are some inbuilt classes in Java that actually allows us to create an instance of those classes. One of such example is the scanner class, which we are going to use in our tutorials for accepting users' inputs, such as a user's ATM pin while withdrawing some money. And we can do scanner, new scanner, and this allows us to create an instance of the class. Although it's expecting something here, which is system in, that tells us that this scanner should be created for receiving inputs from the system. The last thing I'll talk about is what we call typecasting. Typecasting lets you assign a value of one primitive type to another type. In Java, we have two types of casting. We have the widening casting, which is done automatically for converting smaller types to larger types. For instance, we have an integer that is converted to long, or a float that is converted to double. We also have the narrowing casting, which is done manually, that helps us convert larger types to smaller ones. So in this case, let's say we are trying to convert a double to floats or a long to ints. Now I will show you how to typecast. So let's say, for instance, we have a let's say we have an integer, and okay, so we've declared age, let's just say with drawer count is 5, and to typecast this to long, we can do long, we can say count, equals, and then we'll just put withdrawal count. Now you will see that this works because it converts a lower primitive type to a larger primitive type. But if we do the reverse, assuming we have this as long and we have our count as int, you would see it gives us an error and we can just cast. So in order for us to narrowcast, that is to convert a larger primitive type to a smaller primitive type, we would have to specify the smaller primitive type. But for converting a small primitive type to a large primitive type, it is done automatically on the system for us.